Good afternoon. I'm Brian Green from NeuronSphere, here again with Kate Walls. And today we're going to talk about NeuronSphere deployments, specifically deployment of a tested change, although we're going to cross that over with what is this, this is really drift detection between environments. So I want to set the stage a little bit and talk about, NeuronSphere deployment kind of in a larger picture. What is that? What's the account structure that we're looking at? So we've got an account here, which is the control plane. And in here is the deployment service. And so Kate is going to be using the CLI to do some interaction with the deployment service. Now, we have another account over here. And to clarify, when I say account, these are individual AWS accounts being managed in the NeuronSphere ecosystem. So we've got a Kate over here called KMW. This is Kate Walls, and she's got a section of the solution deployed. Actually, she's got a huge chunk of a solution deployed over here. We're going to talk about what does that look like. It's a graph of dependencies. So you kind of pick from the modules that you want, and then it builds a dependency graph. And so she's done some work over here, and she's done some deployments, and she's got some tested changes in a handful of modules. And so we've got another account over here. We've got a test environment, and we're going to do a diff between these two and see what kind of changes are detected. And then we're going to create a change set. So deployments in NeuronSphere happen via a change set. So you create a change set. We'll look at what's the huge change set look like to deploy a whole solution into an engineering account, get started working. We're then going to look at what is the small change set to apply the differences, right? So we're going to bring test up to snuff with our dev account here. And then we're sure that we like what happened and our changes are great. And so we're going to tear this down. I'm going to look at my notes here. I think I got all of this. Yeah. So then we're going to click one button. And because everything that's deployed here is a big dependency graph, we'll click a button at the root of it, basically. And watch, we'll start, burning down, essentially the entire solution in that account. So that is the high level workflow. And we're going to switch over to Kate, and I'll erase some of this maybe and take some other notes, see, some extra commands and things as she's going through and talking about details. Enjoy the demo.
Thanks, Brian. All right, so I'm going to start just by demonstrating that deployment graph for my development environment here. So I wanted to show what that looks like to start out. This is, as Brian mentioned, quite a large deployment. I'll expand everything here so you can kind of get an idea of just how much we have going on. And this is a fully functional deployment of NeuronSphere with all of our latest changes. So you can see here it starts all the way at the base VPC. We deploy our core RDS instance, our base EKS cluster, all the way down here to some of our Kubernetes applications and our microservices. So this is a full deployment of NeuronSphere with all of our latest changes. I just kind of wanted to demonstrate, first of all, what that looks like. Since everything deployed successfully, I'm happy with that. So as Brian mentioned, I'm going to run a comparison to one of our higher environments. I'm ready to move it there, run some additional tests. And so let me switch over now to our deployment CLI, which is what I'm going to use, as Brian mentioned, to interact with our deployment service. And so first, I'm just going to show you kind of all of the commands that we have within this CLI and the ones that I want to use. So the first one here is our compare environments. As Brian mentioned, this is really environment equals AWS account. I'm going to compare my development environment to our test environment. And that's going to give me, spit out a change set, actually, that I can then pass to this command to create a new change set. It's really just some, I'll show you what that looks like in a minute, but it's some configuration with a name so that then I can run this deploy change set command, call out the environment I want to deploy it to and the name of the change set, and off we go. And the last thing I want to do then, since I'm happy with how everything deployed to my development environment, but I no longer need it, I'm now moved on to the next environment, I'm actually going to show what tearing down that whole, all of the resources in that environment looks like. It's expensive to run everything there. I don't need it anymore, so I'm going to go ahead and bring it all down. So the first thing I'm going to do is run this compare environments here.
I think let's look at that diagram. Remember, we were going to look at the pummel.
Yes, I can show that.
I think I forgot to talk about that.
Yeah, let me flip over here. So I'll actually run this Git deployment diagram here. And let me show. I'm just going to tell it here which environment I want it to look like. And it's going to actually just generate a nice diagram with all of those deployments and their dependencies in a nice graph here. So I'm going to run this. And I'm just going to pipe it to a pummel file here. It's written in plant UML. And I'll show what that looks like. Okay, so it's pretty big. And I'll drill in a little bit here and show you kind of what that looks like. Similar to what I just showed in our Argo, where we ran our workflow. We kind of have our microservices and our Kubernetes applications at the top here, because they depend on a lot of other deployed components. And below there we have our microservices, all of their databases, all relying on our core RDS. And over here we've got all of our node group configurations and things relying on our base EKS cluster. We've got a lot that point to our global graph database. And at the bottom of it all, we have our base VPC, which is really the important part here. When I want to go and tear down everything that's costing money in my development environment, I'm going to tear down from this base VPC. And what that's going to do is our deployment service will look at everything that depends on it, which is really everything above here, tear that down first, and then tear down this in order of dependency. Okay, so back to the CLI. I'm going to run this compare environments command here. And if you look here, I'm just passing from environment, my development environment, to environment test. So it tells it what direction I want to compare in. It's going to pull the deployment BOM for my environment, as well as the deployment BOM for our test environment, and run a quick diff.
So if you're looking at my drawing, we're doing this little part right here. Now, one of the things to note that I didn't talk about, we'll talk a little bit while this is going on. This deployment service and what was in that graph. So that graph was a bunch of very orderly boxes with dependencies drawn in between them. Those are all deployable NeuronSphere modules. So there's an entire set of templates and ecosystem. You can use Helm, you can use TFCDK, you can use straight CF. We talked about support for a few others. We are one layer above the infrastructure as code tool, sits the abstraction that the deployment system uses, and sits the abstraction that manages dependencies. And what this has allowed us to do is build a really extensible set of, for things that don't have an analog for deployability, you wrap them all in this same abstraction, and now it's one single dependency graph. So now, some of those boxes that you saw, Kate was very quick to say, oh, this is an EKS cluster, this is this. Those are running, in some cases, a bunch of Terraform underneath, in some cases, Helm underneath, in some cases, other scripts underneath, building all kinds of infrastructure out, but we manage it one layer above, right? So it's a lot cleaner than what you often see in kind of AWS technical diagrams. There's a big mess of things connected, but the idea of what depends on what, right? It's there at a technical level, but not from a deployment change control impact analysis standpoint. So now we're doing drift detection, and Kate's got, here's our change set that we pulled up. But I wanted to talk a little bit more about, what's kind of going on there. And the deployment service is maintaining this graph of what is deployed in tests, maybe analogous to like CloudFormation stacks, but at one higher level. And that's where the state is. So this is maintaining state across all of the different accounts that it manages. And this is what is also allowing you to do these deltas and create these change sets. So back to Kate and the actual change set that showed up here.
Yep, thanks, Brian. So yeah, I can show here what came back is a lot of information here. First, instances that would remove to make the two environments fully in sync. this is what is most important though. Here is our new change set. And I'll drill into that a little bit further. But you can see, we've got some dependencies like Brian was mentioning. In some cases, we have, instance configuration that relates specifically to that repo class. But you can kind of see there's a general structure to each of these. We give it an instance name. There's a repo class that points to the source code, the version of the source code, our deployment ID, an instance configuration, sometimes used, sometimes not, and our dependencies, which just point to instance names within this change set. So I get a full change set, and if you want to go even a step further, it also will drill down to the specific differences that it saw between each of those different repo classes. So for example, what you'll see most often is the version changed. So we bumped up several versions here. Some of them have a little bit different instance config, but typically speaking, what you're seeing is just upgraded versions. So I pulled that new change set into a file here. And as I mentioned, I just give it the change set here in a definition and a name. And this is going to fully define my change set. So now I'm going to flip back quickly to the CLI. And I'm going to create a change set. So I'll pull this up again just to show. I'm going to hit this create change set. And all I'm going to do is pass that file to it. So it has all of the information there that it's going to need. And I spelled definition wrong, which it didn't like. Let me try that again. I can see it's thinking about it. All right, so now when it comes time to deploy, we're going to deploy a change set. I'm going to tell it the deployment set or environment that I want it to go to. That's going to be test in this case. And all I have to do is give it this name that I gave it right here. So I'm going to copy that. I'm going to point to the change set. This is the name. And I'm going to send that off for deployment. And now I'm going to flip back over here. And we will start to see that coming up. This is a separate deployment.
And it is worth noting, I took a bit of a note on the drawing here, but the deployment service is building these DAGs of the deployment dependencies and the individual nodes in it and running them on Argo. But it is worth noting, while this is doing CD, we use this for CI/CD, it's not running Argo CD. So there is a difference there. It is Argo, but it is not Argo CD.
Yeah, so it takes a little bit to think about this because it's running a lot of comparisons and verifying that it has everything that it needs. But we should see this coming up shortly here. There it goes. You can see it's named for the environment that it's being deployed to. So I can kind of let that run in the background. In the meantime, what I'll do here is start running my destroy. So I'm going to pull this destroy instances subcommand, and I'll just show you what we're going to pass to it here. So we're going to pass a deployment set name once again. So I'm going to point to my development environment. And we have this destroy from. I'm going to destroy from the base VPC. That's going to essentially take everything down. And if you notice, if I just run it like this, it actually it sets it as a dry run. That's going to be the default behavior so that you make sure that you know what you're destroying ahead of time. I actually have to pass this no dry run flag in order for it to actually kick off the deployment, but I just wanted to show here what that looks like. It's basically going to just print off all of the instances that are going to come down once I destroy the base VPC, which is pretty extensive here. It's pretty much everything that we have. We've got microservices, we've got our EKS cluster, we have our core RDS instance, essentially everything that's incurring a lot of cost at the moment. So I'll pass this no dry run flag. And it'll actually then kick off a deployment, which is going to run a destroy on all of these instances. in order of dependency.
Let's go look at that other one and see what that application looks like.
Yeah, I just wanted to show it's going to print off the workflow name and give you actually the identifier of the change set deployment. In the meantime, yes, we can go look at this.
Oh, wow.
And you can see it's doing some work here. It actually had to go and upgrade the base VPC, so it's going to do that. It's moving through those changes in order of dependency once again. And I can show here that this is my development environment here. This is the change set that got kicked off to tear everything down. So it's going to start at the highest level, start with microservices and our Kubernetes applications, and move down the dependency chain in the opposite direction as it's running a destroy.
And each one of those nodes is really just an HMD command line command, right? Like, can we see one of those?
Mm-hmm.
So one of the things about it, Kate was using the deployment CLI earlier, but, when the deployment service builds this big graph, what it's really doing is building a big graph of a bunch of individual commands with a bunch of fancy parameters. But ultimately, like everything that it's doing, you could do from a single machine if you had enough information and the right credentials. So it's very much nothing's hidden behind the curtain. It's just that this deployment subservice is doing Uber CLI work for you.
Yep, exactly. And you can see some of the commands that it's passing. Of course, you can see that the Terraform changes here as well. In this case, that one finished. I can show one of these others. That was one of our Kubernetes applications. That's going to be running Helm in the background. And this is one of our microservices. So this is going to be dealing with Lambda and other components there. And let me actually go back to, I can show some from our deployment as well. This one's probably gotten a little bit further along. Looks like it has. So I can show, let me pick on this guy. So same idea, it's going to give you the standard Terraform kind of printout here, show you what it's changing, and that, the resources that it's changed, that it's added, all of that. And you actually see our, in this case, our OPA policies are also getting published. I think we'll have more in-depth demos surrounding OPA in the future. Yep.
So when you do that teardown, you started at the VPC and said, I'm going to tear down everything. What happens to data that you were working on?
Yeah, so effectively, and let me pull up that deployment diagram again. So if we look at what all depends on the base VPC, that is going to take down, for example, our global graph database. It's also going to take down our core RDS, which is right over here. But what it'll do when it takes those down is it automatically takes a snapshot of those databases. So your data is still intact, but you're not incurring any of those costs. And our other data in, for example, S3, as you can see over here, these actually don't depend on the base VPC. So your S3 buckets are going to be left intact. So essentially, all of your data is still there, but at the lowest cost possible, effectively. And so as we do this teardown from the base VPC, that's going to get us to a good state where we could always start back from the state we had previously, just by starting up new instances from those previous snapshots.
Yeah, so we didn't start the demo with that, but Kate started the demo. Kate started her day, by running the change set that installed the entire solution into that engineering account at a known state, so that we could then do this diff, right? So deploying all of this is as easy as undeploying it, with a named change set.
It is. I think it's getting close to the end here, actually. And after that, what we can see is it's actually got some integration tests for some of these deployed components that it's going to run through once it finishes deploying everything. So it'll deploy first, it'll run some integration tests. If those fail, it'll fail the deployment. And you can go and look at the results if needed. Of course, if it passes, then you know that everything's working as expected and you can promote to the next environment.
So the tests are configured automatically against the test environment, so the deployment succeeds, and then we automatically get evidence about, whether it worked or not. Nice.
Yep, and we can actually define these what is called a deployment set, which represents an environment with actually multiple environments chained together. So if, say, we wanted to go through my development environment, our test environment, all the way to prod, we just configure tests at each step, and assuming they pass, it'll move to the next environment, run those tests there, and it'll promote finally to prod. Now, if anything fails, of course, it will not proceed to the next environment. You see here, this is where it's starting to prep for testing. It's actually going to test our transform service, which just went through here. And I'll show you what that looks like in just a moment. But I can show you on the teardown as well. I think there was one failure as well, but same idea. That should have gone through. Yes, over here on our CSI, our EFS CSI, which is our elastic file system. It failed on the first attempt, went through on the second one, and so it continues along its merry way. Let me go show some tests because it's a little bit more exciting to watch. So it installed some test requirements here, and now it's going to run through our test suite for our transform service, which the first one is really just going to load some transform definitions, verify that those all get created successfully. Then it's actually going to run some transforms. So this is and this actually covers a lot of our other installed components as well. It's going to use things like Airflow and Argo deployed in our test account, and verify that everything is working successfully there as well. So this is our sort of like an end-to-end test.
I've drawn a very clear additional thing on the diagram. I don't know if it's actually not very clear at all, but it's like reasonable representation of what's going on.
But that is really our whole deployment process. Did you have anything else you wanted to cover, Brian?
No, I think that's awesome. All right. Well, thanks for going through that. We had kind of a big list and we got through it pretty fast. 26 minutes, I think I've got on the timer. So we started by figuring out what was here, some working stuff. We created a change set based on the differences between these two. We deployed that change set. We started running some tests, and then we are going to have some test results. Thank you.